Okay, hello everybody, and welcome back from spring break. It looks like we're now on a new schedule of 3 days on and 2 days off, unless they've changed it. That's the way it stands at this time of this video was made. We're starting a new unit, and it's called Rational Functions. And the 3 days of this week, we're looking at variation, and we have several types. Today, Monday, we'll do direct and inverse variation. Tuesday, we'll do joint and combined variation, and then Wednesday is a review of that. Obviously, we're not going to turn in a notebook, so no need to take notes anymore, but you will want to pay attention and work along with the videos and with the problems. There's two assignments that you need to download or follow along with today. One's called direct variation. That worksheet is online there, and so inverse variation is the other one. So we'll do both those today, and it looks like there's 10 problems, 5 for each type, and we'll do a couple of each for examples. The answers are also included. Don't forget to check those so you can check your progress. All right, so if you look at the screen there, we have two types of variation, at least for today. One is direct and one is inverse. The difference is in direct variation, you have as one quantity increases, so does the other one. So if you look at y equals k times x, as x increases, it's multiplied by a number, then y would also be increased. In inverse variation, you can see that the equation is, x is in the denominator, so as x increases, y is going to decrease because x is in the denominator. Both equations have a constant called k that is a constant. It's called the constant of variation or the constant of proportionality. Okay, so in the first one, we say that y varies directly as x, or y, and then the second one is y varies inversely as x. That's the way that's read. Okay, let's look at the first assignment that you have there called direct variation, and we'll look at number 1 as an example problem. And I won't write it out here, just read along with me. So it says Trailblazers Incorporated is known for making high quality suits. If they take 9 days to stitch 90 suits, how long would it take them to complete an order of 180 suits? So we know this is a direct variation because as the number of days increases, so does the number of suits that they make. So what you want to do is define your variables that stands for the quantities that you're dealing with. So I'm going to write this as D stands for the number of days that they take to make suits. So D is a number of days. And then I'll use the variable S to stand for the number of suits that they make. Okay, so we've already decided it's a direct variation, and so we can follow that model that the number of suits made equals that constant of variation k. I'm going to write that as with printing there, so k times d. Okay, let's plug in the two numbers that we know. So it says that they take 9 days to make 90 suits, so 90 equals k times 9. And then we divide and solve for that constant of variation. So it's 90 divided by 9, which we know to be 10. Okay, so that's really a rate, right? That's the number of suits per day that they make. So let's take that k and put it back in the equation we started with. So we have S is equal to 10 times D. And then let's plug in our new number. So it says, how long would it take them to complete an order of 180 suits? Well, that's more than the 90 suits that we know. So we know it's going to take them more days. So we should expect our answer to be more than 9 days. And so if it's, just keep that in mind when you finish and check your answer to make sure it makes sense. So we're going to put in that 180 in for S, and so that's going to be, then we're going to solve for D. And then so just divide, and so we got 18 is equal to D, so it's going to take 18 days, don't forget your labels, 18 days to make those 180 suits that they were talking about. All right, so that's number 1. Let's drop down to on your assignment number 4. And let's read that one. So that one says, Aquila Express, the fastest train between Washington, D.C. and Boston, covers a distance of 455 miles in 7 hours. Question, how many miles would it take the train to travel 4 hours? Or how many miles will the train travel in 4 hours? So we would expect that to be less than 455 miles because we're traveling in fewer hours. So that's a direct variation. So I'm going to define the variables to be m is going to be the number of miles traveled. And h to be the number of hours. Okay, so again, it's a direct variation, so my equation is going to be the number of miles equals your constant of variation, k, times the number of hours. Let's plug in the numbers that we know. So we know that they're going to cover 455 miles, so 455 equals that k times the number of hours it took, which was 7. And so we'll solve for k, so we're going to get 65. So that's really a rate, that's miles per hour for our constant of variation. Let's take that k that we just found, put it back in the starting equation that we began with. So m, so the number of miles equals 65 times h, and plug in our new information. So now they're wanting to know how many miles will the train travel in 4 hours. So we'll just plug that 4 in for 4 hours, and then so it's 65 times that 4. So the train will travel 260 miles in 4 hours. So 260 miles. Again, don't forget to put your label on your answer. Okay, so there's 2 examples from direct variation. Let's look at the other worksheet for today, which is inverse variation. We'll do a couple of those, and then all the rest are for you. So on the inverse variation assignment, we have, let's start with number 3 for your example. Let's read that together. At a science exhibit, a student learns that it takes 5 hours for a block of ice to melt if you have it in 32 degrees Celsius. Determine the time it would take to melt that same block of ice at a temperature of 20 degrees. So this is an example of inverse variation. So we would expect that at a lower temperature, it would take longer for that block of ice to melt, or at a higher temperature, it would take fewer hours for that block of ice to melt. So that's an example of inverse variation. Again, we'll do the same thing though. We'll make up variables to stand for the quantities that we know. So I'm going to let h be equal to the number of hours that it takes to melt the block of ice. So h is the number of hours. And d is the number of degrees that it will melt it at. So d is number of degrees. And so we'll do the inverse variation because we know that as one quantity increases, the other quantity decreases. So we'll say that the number of hours to melt this time is going to be k, that constant of variation, divided by the number of days. So we can see from that if k is some constant number, that if you increase the number of degrees, then that's going to be a smaller number of hours that it takes to melt that block of ice. So let's plug in the information that we know. And so it's going to be, we know that it's going to take 5 hours to melt a block of ice if we have degrees at 32. And so just multiply those 2 quantities together. So the constant of variation this time is 5 times 32, or 160. So that's actually not a rate. That's stands for degree hours. Degree times hours, degree hours. Okay, let's go to use that information back to our original equation. So h, the number of hours, is that 160 we just found, divided by 20, because now we're melting that block of ice at 20 degrees. So if we go ahead and divide those, we'll get h, the number of hours, is 8. And don't forget the label. So it is what we expected. We're melting that ice at a lower temperature, so it's going to take longer to melt that ice, 8 hours versus what we had earlier, 5 hours. Okay, one more example for you today. That's number 5 on the inverse variation worksheet. And so let's read that one together. That one says, an airplane travels at a speed of 582 miles per hour To reach its destination in 4 hours, determine the duration of the flight if the airplane travels at a speed of 388 miles per hour. So this is an example of inverse variation. We know that the rate, the 388 miles per hour, is slower, so it's going to increase the time it takes to get to the destination. So our answer should be more than 4 hours. So make sure that makes sense when you calculate your final answer. So again, we're going to make up variables for the quantities that we know. So I'll just use S as the speed of the plane. It's going to be miles per hour. So speed of the plane. And H is going to be the number of hours it takes to make the trip. So H is the number of hours. And because we've decided that it's an inverse variation, we're going to write the inverse variation equation. So the number of hours it takes equals some constant K, which we're going to find. That's the constant variation, divided by the speed of the plane. So as the speed of the plane increases, the number of hours required for the trip decreases. Okay, let's plug in the numbers that we know. So we know that we can make a trip in 4 hours if the plane is traveling at a speed of 582 miles per hour. And again, you're going to multiply those. So the constant variation, K, is going to be the product of 4 and 582. So that's 2,328. So that's hours times miles per hour. So that's actually stands for miles. Okay, let's put that K back into our equation that we started with. So we have H equals 2,328. That's the constant we just calculated, divided by the speed. We have a new speed, so 388. So the plane is slowed down. So again, we're going to expect that the number of hours will increase to make that trip. So if you just divide those two numbers, you'll get H equals 6. And that is longer than the 4 hours we had at a higher speed. So don't forget your label, 6 hours. Okay, there you go. So two examples of inverse variation, 2 examples of direct variation. Go ahead and work those 2 assignments. And tomorrow we'll have a different video for other types of variation problems. Okay, good luck.